Let me welcome all of you to the 11th lecture of Drilling and Blasting Technology course. In this lecture we will continue our drilling machine from the last class. Let us see what we have carried out in the last class. In last class we have learned about the drilling machines and we have covered up to the percussive drilling machine of top hammer drill type. So, this is up to this we have covered. In this class we will cover down the hole hammer drill and other rotary drilling also we will cover in this class. But before starting this class, let me clear it to you that as our today's learning objective is again the same drilling machines and classification, their operations, understanding their operations, but here I would like to assure you that invariably all the drill machine should have start with this is the drill rig, in the top part of the drill rig this is where the actions to be provided onto the drill rod. So, in this drill rig at this position there is a motor or rotor whichever it is required that has to be provided at this, or the hammer, the motive power that has to be required to be provided to the drill steel that must be placed here. Then from this there is a shank adapter. In this shank adapter this basically fit the connecting this power part with the steel, and this steel is basically transmit the power to the bit. So, basically this portion is very important if we want to change anything on our drilling system. So, we would like to change our diameter of the drill, then we have to change this part, that means we have to change the shank. From the shank say this part may be of 4 inch. So, this 4 inch and our drill steel say 6 inch. So, the shank should accommodate a 4 inch by 6 inch coupling, so that this can be converted from 4 inch to 6 inch drill rod. If we replace our 6 inch drill rod with the 8 inch drill rod, then we have to use a 4 inch by 8 inch shank. So, this shank adapter is essentially required for accommodating this drill steel size with the motive power size. So, this part is very important. You must know this shank adapter, then drill steel, then drill bit. This is available for all type of drilling machine. Now, let us start with the rotary percussive drilling of down the hole drill machine. Down the hole hammer, actually this is down the hole hammer drilling. This is down the hole hammer drill, DTH means down the hole hammer drill. So, this down the hole hammer drilling it is also called in the hole hammer drilling, where we place our hammer in the just above the drill bit. The reason of providing this, if we are using the hammer in the top, okay. So, if we are having this is the drill steel, we are hammering, this is the hammer, then a huge energy is lost in the drill steel, which is not essentially required. We want the complete energy utilization by providing the hammer at this position. Second one is that this hammering is carried out on this part. So, this portion of drill steel is subjected to a seismic wave that may damage the drill steel. So, this fearing of damaging of this one also can be eliminated if we are providing a hammer here. but the difference is that if we are using the hammer in the down the hole, then the hammer strength will be less, but that is easily accommodative because as the hammer is utilized on the top of the bit, then the hammer can be utilized, the performance of the hammer is much better than the performance of the top hammer. So, considering this, down the hole hammer is also becoming very popular nowadays. So, this is a method in which the percussive hammer works in the hole during drilling. In this system, the hammer strikes directly on the bit, not onto the drill steel, and no energy is lost through the joints in the drill string. So, basically this is the benefit of using the down the hole hammer. The piston strikes the drill bit directly, while the hammer casing gives straight and stable guidance of the drill bit. This results in minimum deviation and great hole wall stability even in fissures or otherwise loose formation of the rock. So, these are the basic reason which allow us to use down the hole hammer drill in the most of the blasting drilling. So, you can see in this case hammering is carried out in this portion is called hammer, and hammering action is carried out on this case. So, this is the bit, on the top of the bit the DTH hammer is, down the hole hammer is placed. This hammer is basically works from a motive power, which in most of the cases pneumatic, but we may have it is hydraulic also. While we are using pneumatic, our benefit is that the pneumatic air is allowed to travel through the drill steel. So, the air is coming through this drill steel operating the hammer, then coming out as the exhaust from the mouth of the drill bit and allowed to flushing the material from the hole, allowed to flush the material from the hole. So, the same air may be utilized for the hammering action and for the flushing action also. So, that is why most of the down the hole hammer are considered or opted for using as the pneumatic one, because that may be the beneficial. Now, we will discuss the hammer part a little bit later also, but more or less this hammering action is similar to the handheld machine hammering action, the jackhammer hammering action you are using, but only that rifle bar part is not required, because rotary action is not required. Here rotary action is given on the drill steel from the top itself. Okay. So, that differences are there, but anyway that also can be accommodated in the different types of hammering system also. So, basically the driving fluid of the hammer is compressed air that is supplied through a tube which serves as support and makes the hammer turn. The rotation and thrust force are carried out by two separate hydraulic motors or pneumatic motors. So, basically it is pneumatic motors for most of the cases mounted on the surface rigs. So, these actions are given from those motors. Flushing is carried out with the exhaust air of the hammer through the holes in the drill bit. Since the annulus between the drill pipes and the hole wall is comparatively small, a huge flushing velocity is maintained, which contributes further to the hole quality. So, what is happened, as the air is coming through the drill steel. So, consider this is the drill steel, this is the hollow part of the drill steel, then we are utilizing this air in this hammer, these are the inlets, and this is the drill bit which basically have receiving to and fro motion because of the pneumatic motor, operation of the pneumatic motor in this place. And then small holes are available in the mouth of these drill bits, which allow this air to flush out from these small holes. So, as this air, this huge quantity of air is allowed to flush out from a small size of hole, the air velocity is becoming very high, So, as the air is coming out from the mouth of the bit at a very high speed, the flushing of this cutting material is also very good in this case. So, that is why this flushing is very easy for the down the hole hammer. Down the hole hammer method is widely used to drill long holes, because the deviation is less, hammering cost is less, we are not using top hammer, energy utilization is better. So, it is not only used for blasting, but also for water wells, shallow wells, gas wells, for all those cases we are using down the hole hammer drill. However, for very large dia long hole drills, generally we opt for the rotary drilling, not the down the hole hammer drill, because with the increase in the depth, deviation of the down the hole hammer drills are also more, not like rotary holes. From an environmental point of view, the hammer is working in the hole, the noise emission is comparatively low if you compare it with the top hammer drill. This is a particular advantage for the down the hole hammer, especially when the drilling is carried out in a close proximity of the populated area. The strike frequency for down the hole hammer is usually kept between 600 to 1600 strikes per minute, and the air pressure used is between 6 to 24 bar, rotation speed of about 25 to 100 rpm is kept, so that we can have a smooth wall circular hole, and the feeding force is varying between 6 to 20 kilonewton, so that this allow the consistent contact of the drill bit with the rocks. This is in general specification, however, larger specifications, smaller specifications, those are also available. This is in general specification commonly used for the drilling machines used in the mining condition. So, let us have a good look onto the hammer part, but before that the hole ranges of 100 to 254 millimeter dia is commonly used for the down the hole hammer drill. So, this is the hammer part, you can see the air is coming through this, there is a safety valve, this is then the tubular valve is allowing the entering of the air into this. This is the piston, which moves like this way, and this is the outer slip which allow the linearity of the movement of the piston. This is the central tube, allow the movement of this one. This is the chuck, which is holding the piston, and the bit is fitted in the mouth. So, along with the movement of the piston, bit is also being moved in the forward upward backward direction. The holes are placed, 2-3 holes are placed in the mouth of the bit, through which this compressed air will come out and flush the media. So, this is a close look, of the hammer. You can see the raffle bar is not there to give the rotary action, because the rotary action is given onto the drill steel for the complete hammer and drill steel assembly. So, the next classification of drilling is the rotary drilling. we have already discussed rotary drilling a little bit. So, rotary drill basically includes two kind of drilling method, rotary crossing and with tricone bit with fixed bit. So, what is happened in rotary drilling, the rotary action is given onto the drill rod, where a feed pressure is given onto the drill steel. So, that the always this bit rotary bit rotates by rubbing the rock layer, and it is in consistent contact with the rock layer. So, the thrust requirement, feed pressure requirement is little bit higher in case of rotary drilling, because it is action abrasion action is taken by the rotary drilling. This rotary drills comes with two fixed type of bits. One is a drag bit, another is a tricone rock driller bit. It has no moving parts, the bit does not have the moving parts, only the impregnated tungsten carbide parts are there, and it cut through the rock by shearing it. So, basically the drag force are utilized, these drag force are utilized to erase, or you can say fells the rock grains on abrasion, and these beds are mostly used for the softer material, whereas tricone bits are used for the little bit harder material. Most of the time rotary drilling is carried out for the where percussive drilling is not carried out. However, for the large dia and long holes, rotary drilling is always preferred. Now, let us see rotary drilling with tricone rock roller bit. Rotary crossing is a method which was originally used for drilling the oil wells. It is almost nowadays deployed for the minings also, for the especially for the dragline blasting where long holes are drilled. Here rotary applications of the tricone bit is carried out. We will see the tricone bit, figure of the tricone bit in the next slides. Tricone bits rely on crushing and spalling of rock. This is accomplished through transferring down force, that is known as pull down force, to the bit while rotating it in order to drive the carbides into the rock as the three cone rotate around their respective axis. So, three rollers are 120 degree to each other are placed. These rollers rotates at their own axis, and tungsten carbide beads are provided there. I think you should have a look onto the bit first. So, these are the three rollers. So, these are the three rollers placed 120 degree to each other, and these rollers are rolled down. These are the tungsten carbide beads which basically cut the material. So, let us go back to our description. So, all rotary drilling requires high feed pressure, because the consistent touch of the bit with the rock is required, and it also required slow rotation, so that it can properly erase the rock, face the rock grains on shearing. The relationship between these two parameters varies with the type of rock. That means, this is very important, the feed pressure and rotational speed combination is very important if you are considering the type of rock or the drillability of the rock. For the soft formation, low feed pressure, high rotation rate can be used, and vice versa are to be followed, but the exact value depends on the drillability. Rotation of the tricone bead is provided by a hydraulic or electric motor driven gearbox, generally called rotary head, that moves ups and down the tower via a feed system and through a pipe transferring system to the bead. So, now you can see this is the drill rig, and this in the drill rig, in the mouth of the drill steel, this is the tricone rotary bit. You can see these are the bit pin connection. If you take out this pin, the bit will come out. You can replace this from the drill rod. This is the air water separator. These are the lock pins, these are the air tubes, nozzles. Then you can see these are the cutter cones, tungsten carbide cutter cones. These are basically hard fastening which struck with the whole wall. These are the cone and journal thrust buttons. These are the nose air exit valve which allow the exit of the air. These are maintaining the air passage to the bearing. So, these are the different components. You may have a better look on this, and at a later part from the books or from the internet you can have the look of this tricone bit. Now, let us see the other part where the rotary drilling is carried out with the drag bit. Drag bit basically is of two types, it may be a button bit or cross bit. In drag bit no moving part is there, in tricone those rollers are rolling, but drag bit there is no moving part. It is just shear, or cut the rock while it is on abrasion, while it is rubbing the rock surface. So, it is predominantly used for the softer formation. Also it is used for the deep holes also, it is used, but it must be carried out in the softer rock. So, cutting action is basically of drag type rotary drill bit is basically using variety tools which including blade, also the diamond drills are also there where rope and chains and rotary saws are used. So, basically this is drag force are used for cutting action here. The geometry of the device drag action at the cutting surface by two forces, one is thrust and another is the torque. So, basically thrust is giving us the contact of the bit with the rock, and torque is basically shearing. So, basically torque is the main cutting force, and this is the normal force. So, any time if you are try to have this shearing action, this shearing of action is depending on a normal force and a drag force. So, basically this torque is providing the cutting force and this is the normal force you can have. And these are the actions of the drag bit. You can see how these drag bits are crushing at the tip first, then fracturing the rock, then dislodging the chip. So, the action is first crushing, first penetration, then cracking, then chipping. So, action is more or less similar. So, mechanism of penetration of drag bit is that cutting edge of the bit comes in contact with the rock, elastic deformation occurs, then the rock crushed the high stress zone adjacent to the bit, then the cracks are propagated along the shear trajectories to the surface forming chips, then the cracks meet each other, form a chip, the bit moves to contact solid rock and form the chips will taken out, and bit moves again to contact the solid rock surface which which allow again the repetition of the process by crushing, then cracking and then chipping. The edge of the drag bit usually are made of tungsten carbide tip, and often synthetic diamonds, polycrystals are also used. So, most of the cases these are the different types of drag bits. This is commonly used. Diamond drill bits are diamond rotary drilling is also used, where especially for the core drilling, where diamonds are kept in the periphery part only, middle part is kept hollow. So, the rock can be cut in the outer part and the inner core can be taken out easily. So, in this type of bit, if this type of diamond bits are used, that can be used for the core drilling purpose. So, if you look into the rotary drilling, you will find out the shank adapter is there in the beginning, then the first drill rod will come, then the second drill rod will be jointed with the first drill rod using a coupling, then extension rods are there, finally, the bits are there, either it is a button bit or it is a cross bit. Generally button bits are mostly used, the main reason is that the price of the button bits are lesser than the cross bit. However, no one can tell like this, because the cross bit life is more in general more than the button bit life. These are the common accessories we use in the rotary drilling. First is the drill steel. This is basically nothing but the drill rod, though these figures are basically for jackhammer rod, which are percussive for percussive drilling, but these drill steel are basically pipe type of things. These are hollow in the middle with a forged shank. One side is fixed at the one end and another is a forged bit for the case of percussive jackhammer drilling, or another part may be fitted with a bit or may be coupled with another rod. So, these are the integral drill steel, where the bits are placed in the mouth. This cannot be reused. Once the bit is finished, this rod has to be thrown away. So, each drill steel is have a specific length and cannot be extended in this case, and that is why these are limited to this length. Often these rods are used for the handheld apparatus, and in those cases a many drill rod of different lengths are used. First the drilling is carried out with a smaller one, then the next drilling is carried out in the same hole with a longer one, and by this way extended, so that the drilling can be carried out. However, this type of drilling is limited to 2 meter for handheld, but for mechanized using jumbo, this drill length can be extended up to 6 meter also. Okay. Integral drill steel can be extended up to 6 meter drilling length also. Next drilling accessory is the drilling thread. Drill string is that the shank, the drill rod and the bit is jointed together by this thread. So, this string must be firmly connected to give efficient energy transmission. So, there should not be any play in the shank. The most common threads used are of RT and S type. The R thread has a small pitch and a large angle between the flanks. R thread is used in small blast holes with drill rod of 22 to 40 mm dia and powerful independent rotation drills, rock drills. T type thread is used mostly in drilling conditions with the drill rod diameters of 40 to 50 mm. It has a greater pitch and smaller flank angle than the R thread. So, you can say this is the R thread which having a higher the lower pitch. So, if you see this is having a lower pitch than the this is the T thread which is having a higher pitch, and S thread has the same angle between the flanks as the T thread, but a small pitch is used with large extension rod. So, you can see the pitches are of different types, smaller pitches, but it is of large extension rods are provided here. Okay. So, this is called T thread, this is S thread, this is R thread. So, basically S thread is common for the longer drilling length and R thread is common for the shorter drilling length, or you can say rigorous drilling application S thread is preferred over T and R thread. Next is the shank adapter, which is very important, as it is basically enable the percussive impact and rotation to be transmitted to the drill steel from the machine. So, shank adapter is made of high quality special steel with excellent wear resistance, because all the wear and tear and the shearing force is basically withstand by this, and any time if the shank is failed, the total drill will be failed. So, that is why shank is very important, and it should have high strength steel, so that it can withstand all those shearing actions. We have already discussed the shank is also guide the drill steel dia, drill bit dia, and that changing of that one also. Then the drill rod, which is basically transferring the energy up to the bit. This may be shank rod, drifter rod, extension rod, drill tubes, guide rods like this. So, these are the drifter rods which are directly coupled. These are the extension rod, one way it is with the drifter rod, another is that maybe drill bit or maybe the hammer is fitted here. So, basically the first rod is the fitted with the shank is the drifter rod, then the extension rod, then the other things, these are the drill tubes, you can observe these things. These are the couplings which are basically required to join one, drill rod with another drill rod. Okay. So that the desired length of drilling can be obtained, and this is also transferring the energy from one rod to the another rod, or at the end maybe up to the bit. So, this is the purpose of the coupling is required for extending the length of the drilling. So, these are the different types of couplings you can see. This is slip type, this is crossover type, this is full bridge type. So, these different types of couplings are available, which can be used for drilling purpose. Drill bits are of different types. So, basically we are having button bits or cross bits. For the two types of bit, there are some design characteristics characters are common. Most of these rods are threaded to the end of the bit, and that the transmission of impact energy is as direct as possible to the rock. The bit have a series of central and lateral openings through which the flushing medium or flushing air can be injected, and it can also cool down the drill bit. Essentially, our most of the bits are made of tungsten carbide. You can see these are the insert bits, either is of I section chisel type or of this is I section chisel type, these are of cross. These are the button bits, you can see the buttons. You can see the tungsten carbide buttons are placed as per the design specifications. So, this is more or less about the different types of drilling machines. We will continue, few more part of drilling is still left. We will continue with that in the next class. Thank you.